Hello everyone. Today we are going to dive into this adventure of Alice traveling to the world of pods and higher order functions. And it's not just some kind of a fairy tale. Basically, what I want to tell with this talk is that sometimes some knowledge we already acquired can be very relevant and helpful for us in the future in order to discover something completely new. So let's dive into it. I'm Roksolana. I work as big data developer at Captify, and we build a product in the sphere of programmatic advertising, and we have engineering department divided between London and Kyiv, where I work. So also I'm Women Who Code Kyiv data engineering lead and huge Kubernetes and functional programming fan. So you all know probably about Alice traveling to Wonderland and other worlds, and her curiosity sometimes leads her to epic discoveries of the new worlds. So this time she was just visiting her granddad, and in one of the rooms in his house, she has found this weird smooth object which looked like a screen. So she decided to research it closer, just looked into it, touched it, and get sucked into it. She was falling for a while in darkness until her feet reached the surface, and when she got up, she found herself on the lawn in the forest, and she could see this sign reading, "Welcome to the world of pods and high order functions." And now Alice started to feel a bit excited, and at the same time, she was kind of scared because she knew it's the beginning of some new adventure, but she couldn't find out what's going to happen next. But that didn't stop Alice from stepping on the path to a darker part of the forest with a welcoming sign, "Functional Forest," which sounded mysterious as well. So Alice was going on that path for a while until she could hear some sounds of creatures moving around her somewhere in the bushes. She tried to catch this movement, but she couldn't understand what that was until these creatures just got out of there in front of her, and those were the pods, the most simple objects in this part of the world. They looked like brothers and sisters with similar shapes and names. They tried to get acquainted with Alice by just mumbling their names, but Alice couldn't make sense of them. Like what Kafka is supposed to mean, why they are all numbered, and why they are all so similar to each other. So Pods just got ashamed and ran away, and Alice left there confused. She continued her path to another part of the forest, and the trees in this forest were kind of similar in structure and shapes, but at the same time they had some differences. Actually, the branches there were kind of pure functions nested into one another, creating some kind of a flow or cycle, which was the tree itself. But something was weird about them as well. Basically, they were immutable, which means they were not growing. They just existed there, and if new branch kind of appeared, it was a completely new flow or completely new tree. Alice looked around and saw that beneath of the trees there are some weird shimmering light from the flowers. And some objects in this world are kind of too complex for comprehension, like the monads here. But Alice looked into their structure, trying to understand how everything works, until she looked away. She decided that sometime next she will probably get to understand what it was. She followed next on her path and saw that there is some kind of a river dividing one part of the forest and the city, the sound of which she started to hear. And the bridge on this river was kind of breaking already. So she didn't know whether it was safe to step on it, but there was not much choice here. So she crossed the bridge, luckily safely for her, and continued in the forest, wondering why some parts of this world are so strongly divided. Another part of the forest reminded her of her usual world where she lives, so nothing was very special about it, but she could hear the sounds of some cars moving, some people or creatures talking, so she was approaching the city. From the distance, she could see only the silhouettes of the buildings, and something was very similar between all of those buildings. Basically, they were built on top of some building blocks, and although in the end, like the final result would be completely different for any of them. For Alice, it reminded of the constructor details, and that was very true in a way. And also they created their own kind of type system because there were some very simple building blocks getting into more and more complex, and they were connected or inheriting the features of one another and so on. But also they were immutable as well because the buildings in the city should be created from scratch. It wasn't allowed to just mutate some kind of floor in the building and just to build up and up by creating something new. In the heart of the city, there was a factory where probably all of the creatures were created. So Alice thought that maybe this is the place where she can find the answers for her questions. So she followed there. And she imagined that in the factory, she would meet some kind of controllers, managers, someone who would operate the factory, manage some processes in this city. But in reality, the controller, manager, and custom controller she met looked of with some different shapes. But they were very welcoming, and they told Alice that she is now in the city called default namespace. And in this city, there are multiple Kubernetes objects, and also they kind of have derived the functional nature as well. So controller manager said that his responsibility is creation of basic objects, their updates, and their management, while custom controller is responsible for custom objects. And in the factories, you could see that there are maps and schemas for creation of these objects, as well as the mechanisms. So controllers agreed that they would show Alice how everything worked here. Well, part of the schema, which was very general for all of the schemas, and those were the most basic mechanisms operating in this part of the world, consisted of these components. The kubectl, which is a command line tool by which Alice or anyone else can just input some requests, and these requests would be parsed or understood by the API server, which is the hard entity. And API server operates and manages all of the objects in this kind of schema or isolated space. And the data about some events is written into etcd, which is a key value store. And also there is a controller manager she met, and his responsibility is just managing the desired state of the system and the actual one. So trying to map whether the desires of the user work in practice. And the scheduler helps to actually schedule physically the objects which were requested. So that looked easy, but what about the actual mechanism of scheduling the pods, for instance, she met in the forest? So in order to just schedule the pod, she had to input some kubectl create something into the command line tool. Then the request would be sent to the API server, where the event of the creation would be written into etcd key value store. The controller manager would check that the desired state is to have 2 pods in the system, but in reality, we have 0 for now. So he will just push the scheduler that it's time to schedule some pods. And the kubelet here is a new entity which helps to connect the physical location where the pod would be scheduled with all the other entities which work with scheduling, managing, and so on. So the kubelet helps to track whether pod is getting into running state and it's healthy and running. And the kubeproxy allows to build some kind of connection between pods or outside world if it's needed. So this kind of an isolated system with a few entry points for like sending some requests out of the system and getting the results out of it. So it looked pretty logical. But Alice reminded the maze because when you enter the maze first, you don't know where the right turn and whether you should go a few steps backward or forward. So it was pretty complicated, but Alice knew that at some point she will get to the right turn. And sometimes in order to move in the maze properly, you need to have a map. And actually, there was a Kubernetes objects map which would help Alice to figure out what else exists in this world and how it's connected to something she already knows. So she met the pods already, but sometimes the pods are part of the replica set, which is a higher entity, and also they can be nested into deployments, which possess even more properties like deployments, updates, containing volumes, services, and stuff like that, which means they are connected to some other basic objects. Also, there can be a stateful set, which allows to deploy various stateful applications like databases. And actually, Alice met in the forest the stateful set pods because they have the name and the number. They have this ordered nature, which means some processes like updates can be performed in an ordered nature, in an ordered way. Also, there is a daemon set, which allows to schedule a pod on each of the physical location if it's needed and run some utility programs like logging, monitoring, and stuff like that. And there are other objects like services and volumes, and they have so many types, like a huge classification of them. The volume for just storing data in various formats and ways, the services for actually accessing some other objects if it's needed, some other like ecosystems, namespaces, or the outside world, and the job, which is similar to deployment, but it kind of consists of the pods as well. But it runs only once, and after that may purge itself or just stay in the system, while deployment, stateful sets, and daemon sets are running for the desired time. And custom controllers stepped in to remind that there are also the custom resources with their custom resource definitions. And those objects, they are similar to all the previous ones, but their definition looks very different. But at the same time, they allow to manage and create the same basic objects like services, volumes, or deployments if it's needed, which are attached to the specific desired custom nature. So Alice reminded the type system she saw in the city, like one building block nested into another. So basically the functional way would be similar with the Kubernetes way in a way. Because in Kubernetes ecosystem, she would see that there are pods nested into replica sets, which are in their turn nested into deployment. And this kind of looks like a type system. And they are checked against the API server, whether there is a proper kind of object or not. So similar things she saw in the city, also in the forest too, of when she saw the trees with branches. What about immutability? Like when she saw in the forest the trees which were not growing and the buildings which were also immutable, what about Kubernetes part? Well, they are kind of immutable. Some objects, most of the time, if you would want to add some new amount of pods you want to create to add some volumes, they would be rebuilt from scratch and some new deployment, for instance, would be recreated. And also one more like huge aspect is declarative nature. And in order to understand it better, we need to discuss it in more details. So for Alice, declarative nature would look just like that. She would want to have some kind of object in the system without even knowing how Kubernetes lifecycle works, how it's getting to be scheduled, and all the other details. She would just want to have some object and specific amount of that. And she, the person who doesn't care how it's going to be created and scheduled, would just get the object being created without getting again into the details. That's what declarative nature allows, to just say what we want to the system and get this result. So Alice decided that she can try in practice and just deploy some magic database which would contain the data of the stuff she learned here already. All the things she've met, like the pods, the pure functions, the monads, the deployments, stateful sets, and volumes. So all of the things, both from the Kubernetes side and the functional side. But in order to deploy in Kubernetes the database, she would need a Docker image. And controllers suggested her that she can use some kind of basic database image for now, which would just work in her case. So Also, there is an imperative way in comparison to declarative one, but in imperative way, we have to explicitly specify what we want from the system. And in the case of Alice, that might be too complicated from the start. Plus, just running some commands like kubectl create would be kind of boring for her instead of just diving into the definition of objects. Plus, obviously, the declarative way is much higher in terms of features like version control, managing how you change something in the future, going back to it, and stuff like that. So in declarative nature for Kubernetes, there is this magic YAML file which allows to define or describe the kind of objects we want to deploy. And YAML file has its own kind of domain-specific language we write in order to specify the options. So with just one YAML file, we can deploy multiple objects or only one of them if it's needed. So controller manager suggested that Alice should start first with basic objects, because obviously custom objects are built on top of them. So with basic objects, Alice can just create this deployment, and we can see here the kind deployment, defines a name, let it be MagicDB, and the labels for it, which would be useful in the future. Also, there is an image for container, which she used before, basicDB, and the name of this image. Another important features for the database specifically, no matter which database it's that, is the database name, user, and password, which is omitted here. So she decided that let it be the wizard user and the figureTale database name. And here it is, just with kubectl apply f on YAML file, which she called MagicDB as well, she can see what happens after just one definition of deployment. And the deployment is getting created as well as a replica set, although we defined only deployment there. So it looks pretty simple, just with one setup. She has deployment and replica set, and moreover, she has one pod because she didn't specify the amount of the pods, which would be defaulted to one. But what is the point of having a database without storing the actual data? So in order to deploy it properly, Alice would need to have a volume which would store the data. But if there are so many kinds of volumes, how Alice can choose which one to use in this case? Well, first of all, she can go from the requirements she needs. First of all, she would want to have some volume which would be stored for longer period of time, kind of persistent time. So it sounds like persistent volume would work fine for Alice because it's not tied to the life cycle of the pod and just doesn't depend on it. But defining the persistent volume specifically would be just boring, so why not use the persistent volume claim? Basically, persistent volume claim allows to kind of say to the system the requirements we have to our persistent volume, and then we would get this volume from the system. So the simplicity is not only defining the object itself, but the characteristics we require, like the access mode, the request for storage, let it be 10 gigs. And then we need to specify that in deployment as well. So in deployment definition, there should be a specific setup, like where in container our data would be contained, which is the exact mount path, and the volume section. So there are usually two kinds of provisioning of volumes, or defining which ones would be used, the static and dynamic. And the usage of persistent volume claim allows the dynamic provisioning, which means we just don't specify the exact persistent volume we want, we specify its characteristics with the help of persistent volume claim. So what happens if Alice applies these definitions? Basically, the MagicDB claim is created with all the characteristics she required, and the persistent volume claim is created, and they get bound to each other, which means that the API server checked that we want to have MagicDB claim, that we want to have this persistent volume. They are both getting created from scratch, just like that. So in order to understand how it works better, we can imagine that persistent volume is kind of a safe lock. And again, if pod or deployment is getting purged, even persistent volume claim getting purged, we still have our persistent volume and our data stays for longer as long as we want it to have in the system. And the claim here is kind of a note that these are the characteristics of our volume. This is the amount of data stored in there, like the access mode we defined, and so on. So they are kind of bound to each other, but at the same time, they can exist with one another. What about having an access inside of the cluster or the outside world? Well, obviously for that, it would be required to have a service. And the service works like kind of a port. When we have a ship which should unload some cargo or get the cargo, we needed support somewhere. And we would define the service for our deployment. And just note that labels play here an important role because we can map the service to our deployment with the same labels and easily search for such all the objects which are related to the label MagicDB in our system. So we define this specific port, let it be some default port, and the name for this port if you want to refer with some DNS. And here is it. It's like giving the ship the direction. This is where you can unload your cargo or get the cargo, and this is the right way there. So with applying this definition, the service is getting created with the ports we defined inside cluster API, which means that there is access only inside of the cluster. But there can be some other types of accesses like node ports to some outside world, load balancers, and stuff like that. And the service here acts as a bridge, whether it's outside world or inside world to other objects. So for Alice, it looked confusing, like how you're supposed to choose the right type. Okay, you can remember that there is deployment, service, and volume, but each time defining which volume you want to have, which service you want to have, that's kind of a complicated thing. But that's not even it. Like, what is the point with playing with only one pod? That's not very reliable database, even in local infrastructure. So Alice needs to scale it. She defined that maybe 3 pods would be fine enough for her, and when she hits apply, she gets 3 pods running. But paying attention to the age, we can see that the first pod have been living for some time in the system, like his age is longer, while the 2 pods are new. So basically, the first pod has been created from the deployment time, the first draft of the deployment, which means that declarative nature works here as well. Like we want to have 3 pods in the system, we have 1 already, so there is no point in creating 3 of them from scratch. We reuse the previous one and create 2 more. What if we would extend our ecosystem and create 6 replicas? So here we create 6 replicas, which maps to 6 pods. And again, the 3 pods before have like larger age because they've been created for some time already. While 3 other pods are completely new ones. So again, the state which is desired matched to the real one. But just playing and experimenting with this database would be boring before trying even custom resources. So controllers said that they would just purge it with the help of kubectl delete on the file magicdb YAML. So with that, the service is getting deleted because Alice, as a first-time user, defined all the objects, the service, the deployment, all the persistent volume claim in the same YAML file. So hitting delete on one YAML file deletes everything in it. The persistent volume claim getting deleted, as I said, and deployment is getting deleted. But not the persistent volume itself. It just stays again and can be reused in the future by other persistent volume claims by directly specifying the name of it if it's needed. So that's how the basic things work. But what about custom resources? Well, Alice wants to create the custom magic database. And how would that work, the creation of the custom resource with the same schema? Well, it has the same components, but you can see that when the request is sent to API server, then it's sent not to controller manager, but custom controller. And this custom controller is managed by the operator, and they can have their own kind of scheduler if it's needed, all the other features which handle the monitoring of the system and allow to do that in kind of more automatic way. And instead of the pods, it's reading the CR, like a custom resource, but it can be a pod as well. It's just like wrapped inside of the custom resource. So this creation shows that the operator handles here more automated fashion of updates, creates, and all the other things in the system, but also it allows to give some kind of a window for a change because it's possible to alter some definitions of YAML files and so on. So Alice might just have not only a database she wanted, but what about having the whole cluster, for instance, 3 databases? And she can have that with the custom resource definition. That would be like pretty simple. So what Alice has to do for that? Well, she can define the kind magic database because it's a custom resource. And the API version here helps the API server to understand where to look for this kind of object. And let it be some magic wrapper, which, for instance, in this case, contains the magic database object. Also, there is a name, MagicDB cluster, and the namespace, which is default. There is a team ID, which Alice defined as Alice team, just for usage of the cluster itself. The volume, the size of which let it be 4 gigs, and number of instances, because she defined that she wants 3 instances in the cluster. And version, which actually helps to handle in the future some updates and changes in the cluster, especially if they are major and we would want to change the version to 2 or 3 and so on. So the set of users can be defined here as well, and Alice defined that she would be an administrator, and the database would be called Magic World DB with only one user, the admin. So Alice decided that it's her own private database of this world. So when she hits apply, she can see that 3 pods are getting created with the name MagicDB cluster and they are ordered, which means that custom resource here handles the creation of the stateful set behind the scenes, and the stateful set in its turn produces the pods. So now she can go inside of the pod with just the kubectl exec IT, and what happens next? Now she's inside of the pod, and what about just trying to get access to the database? Let it be MDB SQL, and user is Alice. And now she's inside of the database. So with just one definition of magic database kind of object, she has a database. The stateful set is getting deployed with pods, with service, with volume, with all the secrets and configuration definitions she needs for that. But what happens behind the scenes in reality? Well, actually, the MagicDB custom resource is not the only entity running in the system. There is also MagicDB operator itself and the user interface for this operator, which helps to manage the operator in more kind of administrative fashion. An operator here allows to create the config maps, all the volumes, services, role-based access if it's needed for the custom resources. And the operator, as a Kubernetes entity, has its own YAML definition as well. So this is just a glimpse into part of it. This operator is based on deployment, and it has the name, the labels, it has some image, which is DB operator, some version, the service account name for managing their user-based or role-based access, and lots and lots of things for defining these operators. So applying it in the system along with all the other configuration allows to run operator and run multiple databases based on this operator. So in order to deploy something completely else, you would have to define another operator which would manage this entity, like for instance, whether it's going to be Spark application or anything else. Also, there is a config map name, but there are many environment variables in here just to define the proper configurations, which are also changeable. So Alice thought just like that without even thinking what are the basic objects in the system, how it all works. She can define some magic database, define her own options she wants to use, and she has the database running, the whole cluster. She can access it and write some data. Sounds pretty cool. So before controller purged and showed Alice how to actually purge the experiments, she was thinking, like, why not just take this knowledge with her in the actual form? So she thought, like, persistent volume is not getting purged, so why not just take it? Also, she felt like, pretty bad that every time the experiment is over, all the pods are getting purged as well. So why not take the pod with her and explore this world further? So the custom controller showed her that instead of running delete on the YAML file, she can run it on her actual cluster instance with kubectl delete magicdb and magicdb cluster. And that's how her experiment over, but Alice told them that actually the nature of this world, the Kubernetes side and the functional side are very similar, and they may not even notice that. For instance, she already noticed that the type system exists for both of them, like the buildings again and the trees, which consist of the branches. They have their own types and they constitute the type system. The Kubernetes side, where there are pods, replica sets, and deployment, they build their own type system in a way. So it means that they have some similarities between them. Plus, there is immutability. Again, the buildings which are created from the scratch, the trees which are not growing, and the Kubernetes object, like she redefined some deployment, she have to rerun it, and it's getting recreated, as well as the volumes and all the other things. And declarative nature for Kubernetes, she has already discovered in quite a detail. Like it means that she can deploy something and she sees that the amount of pods in the previous examples got increased, but they were not created from scratch. What about the functional nature? Like, is there some declarative side of things? Well, basically there is, because writing the code is kind of a mix of declarative and imperative approach, but if you would just say that imperative way is more about specifying like the exact location in the machine where you would want to send the instruction, then in such a way the functional way is more declarative. Plus, relying on the frameworks we built and some languages specific to these frameworks, they are also in a way declarative. So even with some shades of yes or no, they have some main similarities. But also there is one more thing. Alice noted that there is a YAML file with its own kind of language or domain-specific language, which means that probably there is some functional way for that. And actually, that's true because our functional languages or some built on top of them framework-specific languages are kind of DSLs in their own way. So her knowledge is getting expanded by saying them that they lived in this world but didn't see that the functional way of living and the Kubernetes way were actually getting merged into one another. As the buildings existed in the default namespace city, which is the Kubernetes side of the world, the pods running around in the forest, so they didn't even notice how they started to coexist with one another. While controllers were wondering that it's quite interesting thought, and they didn't even get time to discuss that, Alice looked around and saw that there is an exit sign, and she already grabbed her persistent volume and the pod she hidden behind her back, so she thought she can just sneak around before no one sees her. So she got out of the factory and walked for some time in the streets of the city, but all of the buildings look pretty much similar in a way, and she saw that there is nothing for her to discover in that place. So she tried to go on the opposite side of the city, and while she was going, she could hear the sound of the river, and that just gave her the thought that maybe it's not just a city, but more like a city built on top of an island. So this is probably her way out of this world, maybe. What if she gets to the same place where she was just by going to this river? So she followed there and saw that actually she is now standing on the side of a default namespace city, and another side should be the functional forest side. But the bridge between these worlds on top of the river was much stronger than the one she saw before. So she was wondering whether she just influenced it in a way, because now it looked pretty stable. So Alice stepped on this bridge. She has made only a few steps until it cracked and Alice fell in darkness. And when she fell and opened her eyes, she found herself on the lawn, and the sun was shining like just nothing happened. But she was already in her home near the granddad house. But for her, everything was just changing at that point because she was not alone already. The pod was running around, and she felt in her pocket that there is a persistent volume she grabbed before. So she was now feeling much more like rich with knowledge she got about this world, and she thought that maybe in her real life she can apply something she already know for other concepts which are completely unknown for her. And just by going through all the forest and the city, she just discovered her way out of that place, and she discovered her exit from the maze. Thank you for your attention.